All right, pre-calc, we are continuing on with 8.1. I'll call this B, just to make sure you've already watched the first video. And what we're going to do is examine sort of an interesting thing is E, and it's named after, well, it's actually not named after Euler, but he was the, I guess, founder of this. It happens to be the fifth number he came up with. So just like pi, you know pi to be roughly 3.14. E is also about a certain number. And I'm going to show you a neat trick with a graphing calculator that you'll probably use again in calculus or other future math classes. And if I go to y equals and just type in that formula, and instead of putting in n, I'm going to put in x. And while you're doing this, you might also notice that this looks pretty similar to the compound interest formula that you probably learned a long time ago, or a couple of years ago, where you did the principal times 1 plus the interest rate over n to the n times t power. Well, we take off a few things, and we use, I guess we still have n in there, but I'm using x. So the neat trick that I'm going to show you is you're probably used to tables and doing like second graph and looking at the table. And by the way, n can't be 0 because you'd be dividing by 0. But when n is 1, x is 1, you get a y value of 2. And you could scroll down and you can do when n is 10 or x is 10, you get 2.594. So this is 2 and then 2.594. But I don't know how many of you would really want to scroll down until you get to 100. So this is the trick I wanted to show you, is to quit out of that screen. And if you hit alpha trace, you can actually grab one of those equations, and we typed it into y1, so I'm going to hit enter on y1. And then in parentheses, I can just type in whatever number I want for x. And so you get about 2.705. And I'll show you the buttons again. It's alpha trace to grab that equation, and then in parentheses, we'll do 1,000. And we get this number. By the way, if you don't have this alpha trace shortcut, you can also hit what's called the vars key for variables. And then you have to go over a tab to get to y vars, and then hit enter again, and then grab the function, and then 10,000. Close the parentheses. So x is 10,000 in for this problem. But what you should notice is that the more values I get, it just gets closer and closer to one number. And that's what Euler did, which is kind of amazing when you consider it was the 1600s that he was able to figure this out without a calculator. That we get a number that, after I do a few of them, it's just getting closer and closer to 2.718. Well, so the whole premise of this is, and I'll just write it down here, that we get, you can fill in the chart as you see fit. That after a while, we're just getting closer and closer to n's. So why did I bring up the compound interest formula? 1 plus the interest rate over n to the nt power is, you've probably also heard while you're doing it, the PERT formula is the more compoundings that you do. So if you did 4 compoundings a year, it wouldn't be that much. But if you did monthly, n would be 12. If you did daily, n would be 365. If you compounded continuously, so we had an infinite number of compoundings, then we can use this formula for compound interest. And what does E actually stand for? Well, if we use our calculator, if I hit the division sign, and then enter, see how it's pretty much the same number. 2.718. Whew, that was just a lot. So as n goes to infinity, the value of this gets closer and closer to 2.718, which we call the number e. So e at this point forward is just the numerical value 2.718. Just like pi is always 3.14, e is always 2.718. And why do we do this? This is a very important fact in calculus. It makes it easier to perform operations if we talk about the natural log. That's why it's called the natural base. This is called the natural log. And yes, it is ln. In case you're curious, the English language goes natural log, but other languages would say log, natural. I don't speak the other language, but that's why it's ln of a. So natural log of a is an implied base of e. So why are we bringing that to your attention? Is because we've learned that we can do the change of base formula for these problems. And again, your calculator does, if I hit math, log base, so base 3 of 20, and then we figured out, we learned that we could do, whoops, not that button, alpha x. We could have done log of 20 divided by log of 3. And what the last thing I want to talk about is the button right here is natural log. Whoops, I meant to hit the fraction first. Natural log of 20 divided by natural log of 3. Notice that the change of base formula works for any base. So investigate a little bit more on these next couple and see if it still works with the natural base. Natural log, I should say. So let me scroll down. By the way, the answer key also uses that. Any math teacher will compare e to pi because it's natural to compare those two. Because they're constants. They're always the same number. Okay, I should have mentioned that. So the moral of the story, if you didn't write it down, is that the change of base formula still works for natural log. And it actually works for any. That's why it's called the change of base formula. Is you can change to any base you want to. So go ahead and pause the video, write down anything you need to or anything you deem important. These are your notes. And write down your questions and bring your questions to class. I want to answer them. And as I get to the last page, we're going to find the values of x. And now it is important for you to know how to change from log form to exponential form. Because you can't just go to your calculator and, I guess you could guess and check, but you might be pretty bad at it. It might take you a while. So change it from log form to exponential. So 9 to the negative 2/3 power will equal x. And in this case, what I'd like you to practice is that since we have a negative exponent, to rewrite it as 1 over, this means the cube root of 9 squared. Let's see. Now, at this moment, I'd be fine if you just left your answer like that. I'm not worried about you rationalizing denominators. But if you were to use a calculator, you could just type in 9 to the negative 2/3 power to get your decimal point 231. And double check that your answer makes sense. First of all, the argument must be a positive number. Okay. But if you also think about it, is that this number needs to be smaller than the base in order to get an answer over here that is less than 1. So just to kind of investigate some more, depending on the directions, I might ask you for an exact answer. I might ask you for a rounded answer. Just depends if you have a calculator or not. So in this problem, I would expect you to know the implied base is e. So change it to exponential form. It's e to the 3rd power will equal x. So without a calculator, leave your answer like this. Otherwise, go to your calculator, hit second ln, because we use e to a power so often that we, that's what we're going to see, 20.086. Depending if I ask for a rounded answer, I might expect to see that. So the next problem, change it to exponential form. So we're looking at 3 to the negative third power is equal to 2x plus 1. Now, it would be nice if you gave me the exact value of that becomes 1 over, because it's a negative exponent, 3 times 3 times 3 is 27. And then to solve for x, you're going to subtract 1 over. Let's actually get the exact answer. Well, if I subtract 1 over and getting the same denominator, that would be 27 over 27. I hope you agree that 1 is equal to 27 over 27. So we're looking at negative 26 over 27 when we get the same denominator. And if I divide that by 2, I can just divide the numerator by 2. So I'm looking at negative 13 over 27 is equal to x. Just to show you a slightly different way of thinking of it would be through the answer key. So you can even see he likes showing the rounded answer. I didn't show you this answer for the first example. Oh yeah, he went ahead and did the problem the same way. Okay, so the moral of the story is most math teachers like to see exact answers when possible. It's just when we have these rounded answers. We don't expect you to know e to the third power in your head. That would be kind of obnoxious. Okay. I'm going to keep powering through with showing you how I would do the problem. So change to exponential form to the x power is equal to, well, maybe rewrite that as 5 to the first times 5 to the 1/2. And so you can get the same base, that 5 squared is 25, that x is still there. And if we're multiplying with the same base, we can add the exponent. If the bases are the same, then the exponent must be the same. And if I divide both sides by 2, that's going to just stick that 2 into the denominator. And 2 times 2 is 4. If you're not that good at these fractions, remember, dividing by 2 is the same thing as multiplying by 1/2. So that might help some of you understand why it just goes into the denominator, and 2 times 2 is 4. Looks like we just have 2 more problems. Again, feel free to pause the video and go back and rewatch. I might say something that's, I don't know, confusing, or you just need to see it a second time. So on this next problem, this is kind of weird. The easiest way would be to just go to your calculator and type in. Kind of just want you to do it this way. If you just did log base 2 of 9 and then subtract that 2 over, that would be one way of figuring out what x is. It's kind of a shortcut, but a good problem-solving tactic would be to do this as well. I might be leading you down a bad path. Yeah, let's not do this. This would be too complicated. I believe the answer key, though, uses the change of base formula because a few years ago, even these calculators did not do the log base like I've shown you. So to change log base 2 of 9 to do it that way, and then subtract 2 over, and then you get that approximate answer. I already forgot what it was. 1.170. The other path I was going to take you down was not going to be helpful. And I need to hurry up to make sure I'm done before this video is over. That was the 5th power, right? Change it to exponential form. E to the 5th power is equal to x plus 3. And so subtract 3 over. So you might see me leave the answer like this if you don't have a calculator. But if you do have a calculator, go ahead and do e to the 5th minus 3 to get 145.413. And again, just kind of showing you. Oh, he uses a calculator to get that answer. Ugh, I don't like that answer either. I like the way I did it with you guys. But you do have, don't forget, you can do graphs as well. to find the points of intersection. And you're ready for the homework.